Students, third problem, today's class, there are three charges, 10 nano, 10 nano, minus 10 nano are placed at the corners of an equilateral triangle ABC of side length 4 centimeter. Find the resultant field at the centroid. You know centroid? How to draw centroid? Center of a triangle, equilateral triangle. From that, if you draw a circle, passes through all the three corners. Right? So, 3 charges data, 3 charges 10, 10, minus 10, side length 4. Now, we will go to the solution part. Okay students, this is what he says. There are 3 charges Q1, Q2, Q3 at the corners of an equilateral triangle means angle 60, angle 60, angle 60 here, sides 4, 4, 4. How to identify centroid? Draw perpendicular from the corner C over the side AB. From corner A over the side BC, from corner B over the side, that is AC. I will rub this. So this is centroid, the center of the triangle. Let's mark this some O, right corner. Right. Now what is this angle? This is 30. It divides the angle 60 equally. 30, 30, this side 30. This is also 30, look here, right in yellow color. Then with 30, 30, total angle must be 180. So what is this angle? 120. Now add these three. 120, 30, 30, 180 degrees, that's it. Now let us focus over AOC triangle. AOC triangle, whatever you do with that will be similar, same as AOB, BOC, similar triangles. Now, when the charge is at side, the center O, there are 3 forces. One due to Q1, due to Q2 and due to Q3. Which way? This is very, very important, interesting students. Q3 being negative attracts unit positive charge placed here, right? I write direction of attraction this way. I'll name this E3. My students, what is E3? E3, force due to charge Q3. Remember this. Same time, Q1 as it is positive repels unit positive charge. Which way? Draw a straight line drawn AO along AO extended this way. Let me name this E1. Same time, Q2 also repels this way. What is that? The direction extended BO. E2. What is E2? Field due to Q2, E1 field due to Q1, C field due to Q3. You will see CET need forms like this. Values will be such that you can solve numericals without calculator. Procedure is same. If this is also positive, then you would write direction down, value same, like the different cases. One you practice, the other you must generalize. Now we can use a resultant formula I wrote here. This instead of that, you can go for another easier method. You can reach answer very quickly. That is the resolution method. How to resolve resultant 2 vectors in a given direction. We learnt in the case of electric field due to a dipole on the equatorial line. Similarly, we do here. I will write this part separately outside here. Then I will show how to resolve this part here. I will write here. Then I will show. This is what the electric field directions. This point O. One is acting this way. What is that? E1. The other one acting this way. That is E2, students. And the other one exactly at the middle, bisecting the angle. That is E3. Students, this length must be same. Why? Field as usual depends on 2 important factors, charge and distance. Same for all the three charges. Charges Q1, Q2, Q3 same value wise 10 and distance also same. AO equals to CO equals to BO. That's it. That's why the values must be same. And this angle total 120 I showed you now. This angle 120. So if this is angle 120, See here, this side, if we extend this, if this is angle 120, then this also must be 120, 60 plus 60, 60 plus 60, angle is 120, right? So the angle between E1 and E2 120 degree. Right? We will come to the resultant part later on. Now first of all, in this, you know side length, students, side length. You know charges also, but you don't know AO, CO, BO. What is value side length AO? That's equal to BO. That's equal to CO. You don't know. You have to find in terms of 4. Students, for this, there are several methods. You know, you have learned that using this perpendicular, if you name CD, so 1 by root 3 times CD like that, you know. But this year, you will be using one more relation in trigonometry. Cosine rule, using cosine rule or sine rule. So in sine rule, there is a formula for any triangle, sine rule for a triangle. There is a triangle like this. I will learn this in detail. Remember this now, time being. You are going to prove this, students, sine rule. You don't know. Don't wonder question as to where you learn this. You will learn this in mathematics. This angle A, opposite side A. Let us suppose this way. This side angle B, side B, and this angle C, side C. Then you prove a ratio. The side length by sine of the angle A, sine A, opposite angle, is equal to side B divided by sine of the opposite angle, sine B, and that's equal to side C divided by sine of the opposite angle, sine C. So in our triangle here, what is side A? This is A, right? This is B. C also B here. C also B. Both are same. Why? AO equals to BO. BO equals to CO. That's equal to AO. So this is outside side A and this is B. So using triangle AOC, in triangle AOC, your side A 4 and B you don't know, you have to find. What is A? Angle A, students, angle A opposite to this, angle A, this is angle A. Opposite to this is angle B, this is A. So what is A? 120 degree from here to here. And what is B? B is 30. Therefore, you use this here, 4 divided by sine 120 equals to B divided by sine 30. You have learned this several times. 4 in mathematics. What is sine 120, students? Sine 120 is sine of 180 minus 60, which is sine 60. What is sine 60? Or root 3 by 2. Straight away you will write. Equals to B divided by sine 30 1 by 2. 2 cancels. So the value of B 4 by root 3. In general, if you consider side length A as A, 4 as A, sum A, generally is A by root 3. Therefore, what is the distance between a corner and the centroid is side length A by root 3. A by root 3. If this is in centimeter, write in meter, 10 power minus 2 meters. That's it. Now you know the length. Therefore, what is field? Field at O, even, students, even, see here even, must be equal to E2, that must be equal to E3, that must be equal to 1 over 4 pi epsilon 0, charge Q divided by distance, B square. What is B? B. This is also B, students, same. Okay, write that value, very easy. So, ditto you write. What is 1 by 4 pi epsilon 0? 9 10 power 9. I will got this. What is Q? Q is 10 power minus 9. You don't bother about this minus. Minus sign means you have shown direction towards that charge. Direction already considered for minus sign. B, what is B? 4 by root 3, 10 to the power minus 2 whole squared. So, the value is 9 into 10 because this minus 9 plus 9 cancel. This divided by 16. 16. What is root 3 square? 3 goes to numerator. That's why it becomes into 3. Divided by what is 10 to the power minus 2 whole square? Minus 4. Students, if you write the value, final value, get how much? How much? The value is, this is 16.9, 10 to the power 4 plus 4. This comes to numerator. Do it once again. Or E1 equals to E2. That's equal to E3. Will be equal to nearly 17. 17, 10 to the power 4 Newton per coulomb. Which way, students? Along the direction shown here. A, corner A produces field along E1. What is E1? Along AO. E2 along BO. E3 along OC. Along OC. E3 along OC. Direction shown here. I have taken this outside, put here. E1, E2, E3. What is the angle between these two? 120. Students, observe carefully. Very simple logic. If I extend this, what is total angle? 120. Bisect by E1. Bisecting means dividing equally. This side 60, this side 60. Here also it bisects. So this side 60, this side 60. This side means what, students? Angle between E3, E2. Angle between E1, E2. Now if you find resultant of E1, E2, very simple. Very simple. Resultant of E1, E2. How do you do? Draw parallelogram. Draw side parallel to this. Draw side parallel to this. Exactly they bisect here. Look here. This is. Look at the red arrow. There are two arrows. One yellow. Yellow extends up little bit. That is E3. And red is down little bit, but in the same direction both. Why? Because if the angle is 120, forces equal, angle is divided into 2 equally, right? Angle 60, 60, total angle 120, forces E1 equals to E2. E1 equals to E2 means divides the angle equally. We did a problem, very first problem in the previous classes, maybe class 12, 11, right? So, both E1, resultant of E1 and E2, resultant of E1 and E2 and E3 are in the same direction. Let us call this ER. What is ER? Resultant of E1, E2. They are in the same direction. Final resultant is sum of these two. Addition case, right? Now, you continue this way. How do you continue? First of all, in this triangle, for figure, which figure are shown here? This one. For this figure, resultant of E1 and E2. Which formula are you using, students? Same formula, that is ER square root of E1 squared plus E2 squared plus 2 E1 E2 into cos theta. What is theta between E1 and E2, students? 120. And E1 equals to E2, then you can write E1 only. What is ER? ER equals root of E1 squared plus E1 squared only. Why? Because E2 is E1 plus 2 into, I write here, plus 2 into E1 into E1. E1 into E1, E1 square cos 120. What is cos 120, friends? Cos 120 I showed you in one of the previous classes, and also you are familiar. Cos 120 is cos of 180 minus 60, which is minus cos 60 minus half. You write minus half here, minus half. So 2 cancels. Therefore, we are left with, students, root of E1 squared plus E1 square minus E1 square. So these 2 cancel. So root of E1 squared. I am showing it again. What is root E1 square? Total value, root cancels, that's why E1. So ER equals to E1. Students, remember this once again. I told you to remember it again. If values of the two vectors same, angle 120, then the resultant will be equal to one of the individual forces, E1 are equal to E2. See, values same, angle 120, resultant equals to the first or second value. So what is the conclusion? Conclusion is, if there are two vectors acting at an angle 120 E1, this E2, then the angle is 120, resultant exactly bisects. What is the resultant? That is also same. And in the same direction you have one more. What is that? E3. As the two are in the same direction, as E3 and ER, resultant of E1, E2, are along same direction or parallel. Right, look here. I write parallel. Then final resultant is the sum of E3 and ER. Very simple. Therefore, final resultant is what? E1 plus E3 plus ER. What is E3? ER is also same. E1. So E3 plus E1. What is E3? E1? Both same. What is the value? 17 10 power 4. Therefore, it is 2 times E1 only. Because, why students? Because E1 equals to E2, that's equal to E3. Therefore, E equals to 2 times E1, 17 10 to the power 3, 4. That is 34 10 to the power 4 Newton per Coulomb. Along which direction? I write final value, final answer. Let us remove this. You know this part. Let us remove. Therefore, the resultant vector E is 34 10 to the power 4 Newton per Coulomb. Along which direction, students? Direction is very much clearly defined along OC. Very simple. You need not use resultant formula. That is tan alpha equals to E cos theta by or E2 cos theta by E1 plus E2 sin theta. You need not use that. They are parallel. That's why resultant is in the same direction, OC. It's very simple. See, very, very simple and easy. You must practice this 2 times. Students, observe 2 times carefully. Close the switch off or close the video. Take pen and book. Go on writing on your own. If you miss a step or a method or a formula in between, go through the video once again. Right? Play it once again. Go through the simplification part. Try it again. This is very, very important, this part. Whenever we use this, you must recall all these relations. Right? And one more thing I am repeating. If the two forces same, angle 120, what is the resultant? Same. If P equals to Q, angle theta 120, then resultant R also equals to P. Here P is E1, Q is E2, resultant is same. E only. E equals to E1 or ER equals to E1. Since E1, ER is parallel to E3, ER is parallel to E3, you just add these two to find the total resultant. Like this you have to practice, students. Very, very important. Go through the calculation part. Now I will give some homeworks, right? We will see that. Okay, students. You try these sums in your study material. Page number, let's see page number. It's page number 16. In page number 16, you have problems for your practice. You try question number 2 as homework. I will tell you about 1 later on. You try this at home after this. You must try and send me the solution part. You have the answer. If answer is different than the given here, you tell me your answer. I will check it out once again. Sometimes answer may be different. And this is 10 raised to the power 4, students. 10 power 4. Sometimes some minor mistakes you can easily make out. Understand what it is. There are 2 charges, 16, 8 and side length given, this is in meter, centimeter, 3, that's it, 3 centimeters, 0.03 meters. Try this at home. And you have one more I'll give you, right? That is this one. Okay, 10th one you try. 10th one also a homework problem. Try this. This is to find what is force acting on it. Force acting. Same equilateral triangle, 2 charges, side length given, other charge is there. You try this at home. A homework problem. You try same, right? So next one you can try this also. This charges 0.5, 2 minus 2.5, 0.1 micro are held at the corners A, B, C of equilateral triangle side 5 centimeter. Find the electric force. You have to find force. Formula changes now. What is the formula for force? F equals to 1 over 4 pi epsilon 0 charge Q1 Q2 divided by R square. You already done in previous videos, problem 1, 2, 3, right? You try it. Now next, this is also homework, very similar to the one we discussed in last 3 videos. First one, this homework, 12th one. 2 charges 10 micro, 20 micro are placed at the corners of hypotenuse of a right angle triangle, side length AB 3 meter, AC 4 meter. He has already given AB, AC. Calculate resultant electric intensity at corner A, right? At corner A, you have to find resultant intensity. What is right angle here? Right angle is this, right? Right angle is this. Can you try this? Try, and I'll give hint, very simple. I'll give hint. So this is a right angle triangle, students. This corner A, this B and this C. There are 2 charges at corner B and C. So see here, 2 charges 10 micro, 20 micro are placed at the hypotenuse BC. Hypotenuse BC means this is B, this is C, then A is the right angle. One charge is here Q1, the other is Q2. The rest of the calculation same as second problem, today's class, right? Today's class. I'll rub this. I'll go to one more homework problem, that is here down, maybe in the next page of your book, this one. See 70. AB is an equilateral triangle of side 1 meter, midpoint BC, charges 4 and 4, 3 are placed at BCD respectively. Find the resultant electric intensity at corner A. So this is the hint. So an equilateral triangle, right? This is A, B, C, and this is D. One charge is here Q1, second charge Q2, and third charge Q3. You can easily find. Electric field to one charge this way, E1. Electric field to second charge this way, E2. And electric field to this charge along this direction, E3. So what is the resultant of these two? Will be along this direction, same, ER. Same procedure as we did in the previous problem. E1 1 over 4 pi epsilon 0 BA square. E2 1 over 4 pi epsilon 0 CA square. What is E3? 1 over 4 pi epsilon 0 dA square along this. Now you find resultant of these two. Same formula, root of E1 square plus E2 to E1 E2 cos theta. Theta is 60 degree now, not 120, 60. You have to find. That resultant adds up with E3. You find the sum of E3 and E1, ER, that will be your answer. Which direction? Along DA, that's it. You try that, very easy. I hope you will try, right? So these are some problems. I'll give some more as homework in the next class. You try these, send me the answers. We'll continue in the next video.